Hi friends, welcome back. So we will continue with our video series data structures and algorithms. Today we are going to see some of the main differences between the array and linked list. So in the previous two videos we have covered array and linked list. So if you have not watched those videos, I request you to watch those videos so that you can understand this video in much better way. Okay, so let us start. So what is the difference between array and linked list? So before going to the differences, first we will go to what is an array. So I will just give you a brief idea of what is an array. So array is a collection of data which you can store in continuous memory locations, and linked list also is a collection of data items, but it will not be stored. It is not necessary that it will be stored in the continuous memory locations. It can store anywhere in the memory. So when you talk about the computer memory, you can say that the two most important parts of the computer memory is stack and heap. So in the stack memory, we have all the locations properly arranged. Okay, so it will be like a stack of plates, like you can say, where each and every memory location is properly arranged. But in heap, it is not the case. It is like not in an ordered position. It can allot the memory location anywhere in that particular portion. Okay, there are some methods and data types which we store in the stack area, and there are other types which we store in the heap area. Okay, so just understand that stack we have the memory locations properly arranged, and heap it is not, the locations are not properly arranged. Okay, so now we will see the differences between the array and linked list. So first we will see where these array elements are stored. Okay, so like I told you, these array elements are stored in continuous memory locations. Okay, when you define an array at when you write the program, like in the example which we saw in the array video, we have a number of players there. So if you have 5 players, you want to store the names of 5 players, or you want to store the marks of 5 students, then you define that you want to create an array with the length of 5. Okay, so and I want to store the marks of the students in that particular array. So what the memory does, so memory just allocates a memory locations where you can store these 5 values. Okay, so when you define as I need an array of length 5 that is named as marks, then the memory allocates the 5 locations for you to store these values. So you have to define the length of the array. Okay, so when you write the program, so when you write the program, at that time only memory will allocate these locations, so you can store these values. So you have defined that you need an array of a length of 5, but it is not necessary that you will use all these 5 areas. So after defining that, you understood that okay, I have only 3 students in my class which I want to store the marks. Okay, then you will use only the 3 locations in that particular array, and the remaining 2 will go on waste. So it is not used. But when you create a linked list, you don't define the length of the linked list. So the when you create a linked list, the allocation of this space or the location to store this value is allotted at a runtime. That is when you run the program. Okay. So when you run the program, so you first you want to add the student, then mark of the first student, then the memory will allot the space for that. It will also store in that particular node, it will also store the location of the next value. Okay, so when you store the next value, so this memory location is allotted, and you will get the address of the second the student's marks from the first student's node. Okay, so in linked list you have two parts. When a memory is allocated, you have two parts. One is for storing the data, that is the mark of the student, and next is for the storing the address to the next node or the previous node. Okay, so when you talk about the cost of memory, then you can imagine that when you store an array, you need only one location. Okay, that is for storing that particular value. For example, the mark of the student. When you want to create the store the mark of the second student, it will be allotted next to this previous memory location. But when you talk about linked list, you cannot only have the location for storing the value, you should have the location for storing the address to the next or previous node. So it will have the almost double the size which is required for the storing the array. Okay, so that is the another difference between the array and linked list. So if you need a memory size of 8 for storing the array value, then you may require the memory size of 16 to store a linked list element, because it has to store the location to the next or previous node. So next we will talk about the next difference between the array and linked list, that is ease of finding an element in that particular data structure. So for example, you have the array of the marks of the student, and you want to find out the mark of a particular student. For example, if you want to find the mark of a third student, then how you are going to write the code? You are going to write marks square bracket 2, because I am writing 2 because the array starts from the element 0. Okay, so if you want to find the mark of the third student, you will write like marks 2. Okay, so you can directly access the value in an array using the index. Okay, so for example, if just imagine that you want to meet your friend in a hostel, and this hostel has got the numbers like 100, 101, 102, 103, like that, and you know that your friend is staying at 105, room number 105. Then if you find the room number 100, okay, then it is very easy for you to find the 105th room, because you can just count that from 100, 101, 102, then you know that which is the 105 room. Okay, so you don't have to knock in each and every room and ensure that whether my friend stays here or not. Okay, you don't have to do that. You know that after 100, in the fifth position is my friend's room. Okay, so you can directly go to that particular room. Okay, So that is the how you can find a element or this member in an array. But what happens in when you try to find a element in linked list? So like I told you, linked list, it is not stored in the continuous location. It can store anywhere in the memory. So in linked list, the first element has got the address of the second element, and second element has got the address of the third element, and third element has got the address of fourth element. So if you want to find out the fifth element, what you have to do? You have to go to the first element first and get the address of the second element, and you have to go to the second element and get the address of the third element, like that. And so if you want to find a particular element, you have to travel from the head to your target element. For this array, I gave you the example of a hostel. But when you talked about this linked list, you can see like it is a busy or a crowded neighborhood. Okay, so you don't know where your friend lives. So maybe first what you will do is that when you enter that neighborhood, you will first go to the first house, and you will inquire about a particular person, and that person, the owner of that house, will give you the address of the person who may know your friend, and that he will give you the address of that particular person. When you go to the house of the second person, he will give you the address of the third person, and that when you reach the third person, he will give you maybe your friend's address. So it is not necessary that if you find the address of the first house in that neighborhood, you can imagine what will be the location of your friend's house. Okay, so because it is all the houses are scattered here and there, so it is not easy for you to guess what will be the location of your friend's house. Okay, so finding a particular element in a data structure is easy when you store that in an array than in a linked list, because the array, the elements are stored in a continuous locations, and in linked list it is stored in different locations. So we have to start from the beginning to your destination. Next we will go to the next difference between the array and linked list. So now imagine that you want to add a particular element in the start of the array. Then what you have to do? For example, if my marks are 10, 20, 30, 40 like that, and if you want to add a mark of 5 in the start of the array, then what you have to do? When you add the 5 as the first element, you have to shift all other elements to the right. Okay, so like if you are earlier your first element was 10, but if you are adding the 5 as the first element, then you have to move the second element, that is the mark of 10, to the right, that is in the first position. I mean the index number 1, and which was previously in the index number 1 will be shifted to index number 2. Like that you have to shift all the elements to the next position. Okay, and if for example you have the length of the array as 5, okay, and you have added 3 elements, so there is no problem. When you want to add the fourth element as the first element, you can just shift all other elements to the right. But imagine that if I have the array of 5 and I have already entered the 5 elements there. Okay, if I have the length of the array as 5 and I have added 10, 20, 30, 40 and 50 already. And if I want to add the another student's mark, that is 5 in the first position, then I cannot move it again to the right because there is no space available. There is no memory location allotted for me for that. So what I have to do? Then I have to again define another variable, another array, and I have to copy all these all these elements from the previous array to the new array. Then only I can this include this new value in that particular array. So it is little bit difficult for you to insert one element in an array if it is already full. Even if it is not full, you have to shift those values, the previous values, to the next position. But when you talk about linked list, if you want to add a new element, it is not difficult because you are not it is not stored in the continuous position. Okay, so it is the memory will allocate you a new position for storing that particular value of 5. Okay, and you have to just store the address of that particular new location into the previous node. Okay, so when you consider this storing a new value in this particular data structure, it is easier to do that in linked list than in an array. So when you consider adding when the new element, you can use the linked list. Okay, so I hope you understood some of the difference between the array and linked list. So array is stored in the continuous locations in a memory, and if these are index based, array is index based. So if you know the index of a particular element, it is very easy for you to find the element which is in that particular index. But in linked list, this is, you don't know the address of a particular element. It can be anywhere in the memory, and each element of the linked list is called node. It contains two parts. One is for the storing the data, and the next is for the storing the address of the next or previous node. Okay, array you have to declare at when you write the program. Okay, so when you write the program, you have to declare the length of that array, and memory will allocate those number of memory locations for that particular array. But in linked list, the locations are allocated at a runtime. So if you have the you have the first student, you just have to define the location. You have to just define the mark of that particular student. Then at a runtime, the memory will allocate the location to store that particular value. And in the later stage, when you want to store the marks of the second student, then memory will allot the position to store that particular student's marks. And this is the same with the third student, fourth student, like that. Array, you don't need that much of memory for storing a value because you are storing only the value. But in linked list, you require more memory because you also want to store the location to the next node. And when you want to find a particular element in that data structure, array is better because if you know the index of that element, you can find the element. So, but in linked list, you have to start from the beginning and till you reach the destination. You have to go to each and every node and get the address of the next node. So which data structure you are going to use when you create an application? Okay, so you cannot say that the array is better than linked list or linked list is better than array. So this depends on your requirement. So what is your requirements? So if you know exactly like how many students you have, how many elements you want to store in a particular data structure, then you can go for array because it is not going to change. You are confident that it is not going to change. But if in case if it changes, then you have to create a new array. But if you don't have the idea of what could be the number of elements in that particular data structure, then you can go for linked list because linked list allocates the location at a runtime. So even if you have no idea of how many members will be there, or you want to add more elements at a runtime, then it will not be difficult for a linked list to do that because it allocates the memory at a runtime. So depending on the your requirements, you can choose which data structure you want to use. From if you want to use the array or you want to use the linked list. So I hope you understood some of the difference between the arrays and linked list. In the next video, we will continue this series of data structures and algorithms. And thank you for watching this video. Thank you so much.